In Gases 8, I'm going to talk to you about molar mass of gases. And we're going to start right off with a practice problem. In this video, we're going to be using what we've learned throughout this entire unit and what we've also learned in previous units, and using that information to calculate the molar mass of a gas. Now, we've done this in previous units. For example, recall in our studies of stoichiometry that we learned how to identify an unknown metal. How did we do that? We used the molar mass, the grams divided by the moles, to calculate and ultimately identify an unknown metal. In these practice problems, we're going to use the molar mass, and we're going to be calculating the molar mass of a gas, along with many other really cool things. I'm also going to demonstrate in lab some of the techniques that you're going to be using in an upcoming lab investigation. Let's get to this problem where we have 1 gram of a gas and it's collected at a given pressure at room temperature, and we have 250 milliliters of the gas produced. Whereas, what is the molar mass of the gas? And we know if we're doing molar mass, I've implored you throughout this course, we're going to kind of write down somewhere on your paper, however you're doing this, grams over mole. That way you can keep everything straight in your mind. Well, we're already given the grams, so this is a straight application of the ideal gas law. It's all about the mole. We just need to convert what we have to calculate how many moles of the gas. Once we do that, we can simply plug it into here and move on. So let's do the usual. Let's convert torr to atmospheres using dimensional analysis and the fact there are 760 torr in 1 atmosphere. We've already converted Celsius to 298 Kelvin. However, we have a gas that is collected over water. That means we're going to need to compensate for the vapor pressure exerted by water and include that in our calculation so that we can compensate for its pressure and ultimately get the pressure exerted only by the gas of interest. All right? So in other words, we're going to subtract out that vapor pressure. So here we have our 0.753 atmospheres. And just like we've done in the past, where did this number come from? From the table. From the table I just showed you at 25 degrees Celsius. Then we're going to convert the millimeters of mercury into atmospheres by dividing the quantity on your table of 23.7 by 760 millimeters of mercury, and that's going to give us our new atmosphere, our new pressure, that is the pressure only exerted by this gas of interest. So we've subtracted the pressure of vapor exerted by the water. Now we can use the ideal gas law, and we can rearrange this to solve for the moles of our unknown gas. We have everything we need. We can put this into the ideal gas law equation and finally solve for moles. With 3 significant figures, we get 7.38 times 10 to the negative third moles of this particular gas. We know the grams that we have of this gas. We're only dealing with this gas. We're not doing any stoichiometry in this problem. A lot of students say, well, aren't we doing stoichiometry here? No, we don't have anything to write and balance a chemical reaction. We're given everything specifically about this gas and under these conditions. So we just simply need to find the moles of gas, and then lastly, look at this quotient here. And 1 divided by the moles of our substance yields 136 grams per mole. That is the answer. 136 grams per mole is the molar mass of this particular gas. Now, there are many applications of this idea of molar mass of gases. We're going to explore them in lab. You will be using stoichiometry. You will be calculating empirical and molecular formulas. And right now, I'm going to take you to a demonstration in our lab showing you how to use a eudiometer in our upcoming lab investigation. In an upcoming lab, you're going to be using a piece of equipment known as a eudiometer. Now, a eudiometer is used to accurately measure the displacement of a liquid by a gas. Specifically, you're going to be conducting a single replacement reaction in which magnesium metal reacts with hydrochloric acid. In the eudiometer, I have placed approximately 6 milliliters of 6 molar hydrochloric acid. Please be very careful when handling concentrated acids. Now, it does not have to be exactly this volume because you're going to use stoichiometry and the ideal gas law to ultimately calculate the experimental value for the ideal gas law constant. Next, I have fashioned using a 0,0 size stopper, a cage. And this cage, which there's a schematic on the lab diagram, is holding a 4 centimeter piece of magnesium. The magnesium has been polished with either scissors or sandpaper to remove any oxide. Next, I have used copper wire to create a cage to hold the magnesium. I will now be adding blue food-colored water to the eudiometer, which contains the concentrated acid. I will be doing so very slowly, pouring the blue water down the side of the eudiometer. I will do that all the way to the top. Now, the acid is more dense. So you can see a difference in the color here of the blue food coloring water and the acid at the bottom. Next, I will be placing the stopper with the copper and the magnesium into the eudiometer as such. I will then invert the apparatus into a large beaker full of water. You may or may not choose to use a burette clamp to hold the eudiometer. Alternatively, you may choose to simply hold the eudiometer on your own. Now, what you will see is that as the acid mixes through the water and down to the magnesium, you'll see the evolution of a gas. And you know from your studies of chemistry thus far that this gas is a diatomic hydrogen. So you can see the gas is bubbling through the water, and the eudiometer is measuring the displacement of that gas. As the reaction approaches completion, please be aware that your water located inside of the large beaker now contains a dilute acid. That dilute acid is still something that I would like you to be very careful working with. In other words, there is no longer simply water in here. It is now dilute acid. Please be careful. Now, once the reaction has gone to completion, you will be able to measure the displacement given the initial volume of water inside the eudiometer and the finishing increment after the reaction has completed. From there, you will use the ideal gas law, stoichiometry, and Dalton's law of partial pressures to experimentally determine the ideal gas law constant. So in this video, you've learned how to calculate the molar mass of a gas. You've learned how to relate volume, temperature, and pressure to moles of a substance, convert moles into grams. You've learned about stoichiometry and converting moles of a gas into grams of a gas using stoich and the ideal gas law. And you know we're going to be applying this in our upcoming lab to experimentally determine the ideal gas law constant. I'll see you guys in class.